Hello everyone, today in this video I'll be explaining the acidic character of alcohols. Now firstly, when we see the acidic strength, means the ability of a molecule to release hydrogen as a proton, that is H+. Now firstly, when we compare the structure of water and alcohols, our water molecule H2O and alcohol, we will notice that the structure of water H2O and then the structure of alcohol ROH, they are similar here. Now in water molecule, let's take this OH bond. In water molecule, the OH bond is attached to a hydrogen atom, whereas in an alcohol, the OH group is attached to an alkyl group. Alkyl group, we know that alkyl groups, they are electron releasing groups. Therefore, the presence of these alkyl groups in alcohol increases the electron density. It increases electron density at oxygen atom, and as a result, oxygen in alcohol shows lesser tendency to withdraw electrons, to withdraw the electrons from hydrogen atom. This increases the polarity. When this happens, the polarity of the OH bond increases. The polarity of the OH bond decreases, and therefore the breaking of this OH bond becomes difficult. Thus, from this we can also say that the alcohols are weaker acids than water. Now here, oxygen being more electronegative than hydrogen, they will pull the bonding electron towards itself more, and thus towards the OH group, and then hydrogen can be easily released as a proton in water molecule, whereas in alcohols, because of the presence of these R groups, the electron withdrawing groups, the electron density on oxygen atom is increased. Thus the polarity of the OH group, the polarity of the OH bond decreases, and thus the breaking of this OH bond becomes difficult, and thus we say that the alcohols are more acidic than water. Now we know that alcohols are more acidic than water. Now what happens when we compare the acidic strength of our primary alcohol, primary, secondary and tertiary alcohols? Now let's write the structure. Let's write general primary alcohol, secondary alcohol, and then our tertiary alcohol. Now here, from this, the explanation on water and alcohol, we know that the presence of one alkyl group attached to our OH group increases the electron density on oxygen atom, thereby decreasing the polarity of the OH bond. Thus, here in primary alcohol, we have only one R group releasing electrons. In secondary, we have two R groups releasing electrons, while as in tertiary, we have three alkyl groups releasing electrons. Thus, the presence of this alkyl group in alcohols, it makes the OH bond less polar. It makes the presence of this less polar. The polarity decreases due to the electron releasing tendency, or we can say the plus I effect of the alkyl group. So the presence of the alkyl group in alcohol lowers the acidic strength of alcohols. Now since such effects increases in going from, we see here that the effect is increasing. We have here plus I, the effect is increasing, the electron releasing tendency is increasing as we go from primary, secondary to tertiary alcohols. Hence, the breaking of the OH bond becomes more and more difficult in going from primary to secondary to tertiary alcohol. Thus, we see, therefore, the acidic strength will go on. Acidic strength decreases. Therefore, our primary alcohol will be more acidic than secondary, and secondary will be more acidic than a tertiary alcohol. Therefore, from this we see that the acidic strength of alcohols is that primary is more acidic than secondary, then a tertiary alcohol, because the electron releasing effect increases as we move from primary to secondary to tertiary, and thus the breaking of the OH bond becomes difficult. Thus we we can notify the bond outer is primary is more acidic than secondary than tertiary. Now, let's see the acidic character, acidity of phenol. Now, we see phenols behave like weak acids. Now, if we see here, they behave as weak acids because these are phenol OH. Due to the presence of the ionizable, the polar OH group, which ionizes in this way. This is the ionization of our phenol. Just in this way. This is our phenoxide. It ionizes easily into a phenoxide ion. Because of that, our phenol is considered as a weak acid. Now, if we compare the acidity of phenol and alcohol, molecules of phenols, let's write here one OH and then a phenol here. Now let's compare the acidic strain of alcohol and phenol. Now in alcohols, the alkyl group is attached. The alkyl group is electron releasing groups. Now because of this, it increases the electron density around the oxygen atom. So the oxygen atom will show lesser density. Let me increase the bond here. Okay. Since the alkyl group releases electron towards the oxygen atom, this increases the electron density on the oxygen atom. So the oxygen atom will show lesser tendency to pull the electron towards itself. As a result, the polarity of this OH bond decreases. Polarity decreases. And therefore, the acidic strain of alcohol, acidic strain of alcohol decreases. Now, on the other hand, when we see in phenols, we know that the benzene ring is our benzene ring is an electron withdrawing group. Now, so it decreases. It will obviously decrease the electron density on the oxygen atom. That it will pull the electron towards itself. That the oxygen atom of the OH group. As a result, the oxygen atom will tend to pull the electron towards itself. Now when this happens, it will increase the polarity. Polarity increases. This increases the polarity of the OH bond in our phenols. Thus, phenols, they behave as stronger acids than alcohols. Now therefore, the acidic strength would be in this way. Phenol is more acidic than our alcohol. Now in phenols, how do we study the acidic strength of phenol? Now, we have the effect of resonance on the acidic strain of phenol. Now, when we see the acidic strain, now phenol exists as a resonance hybrid of the folic structures. Let me draw the structures. Phenol, OH, there are two pairs of electrons. Now, in the second here, OH, if this electron comes here, this shifts, then we'll be getting our third resonating structure. The electron density would be here, OH bond here. The oxygen atom acquires a positive charge. Now, if this shifts here, this bonding by electron shifts, and then we get here, electron density is here, and then here. Now, again, if this shifts, this will go here, and then we'll be getting now if this comes, the electron goes back, and then let me write here, we will be getting back our phenol. Now from here, in these resonating structures, this is structure 1, this is 2, 3, 4, 5, and 6. Now if we see here in structure 2, 3, and 4, and 5, we see that the oxygen atom due to resonance, the oxygen atom of this hydroxyl group acquires a positive charge. Now, when this happens, this will make the release of our hydrogen atom as an H plus as a proton easier. Now, since however we know that resonance is not possible in alcohols, hence the hydrogen atom in alcohol is firmly attached to the oxygen atom of the OH group in alcohols. As a result, the hydrogen atom of the OH group in alcohol is not it cannot be ionized, and hence alcohols behave as neutral. Because of this, the effect of resonance in phenol giving our oxygen atom a positive charge makes the hydrogen atom it makes the release of a hydrogen atom as H plus easier as compared to alcohols where resonance is not possible and the hydrogen atom is strongly linked to the oxygen atom. Now, in addition, if we see that the phenoxide ion, that means our phenoxide ion is this. In the phenoxide ion, we see here that the phenoxide ion formed due to ionization of phenol also it exhibits resonance, and we know that the phenoxide ion is more stabilized relative to phenol molecule due to resonance. Let's draw the resonating structure. If this comes here, and then electron density increases, acquires a double bond. If this comes, this will shift here. This comes here, and then we'll be getting here electron density. This goes back, and then we'll be getting back our phenoxide ion. Now here we see here that even the phenoxide ion is more stabilized than phenol due to the resonance, and therefore we say that phenols are more acidic. Phenols are more acidic than alcohols. Now, electron withdrawing groups, that means electron withdrawing groups, for example the nitro group, the cyano group, and then the halogens, they will increase the acidity of phenol, whereas the electron releasing groups such as the alkyl groups, the alkoxy group, the amino group, and then the OH group, they will decrease the acidity of phenols. Therefore, from here we can conclude that our phenols are more acidic than alcohols, and even in alcohols, the primary is more acidic than secondary than the tertiary alcohol. Because of their increase in the alkyl groups, the release of the hydrogen atom as a proton becomes even more difficult. And when we compare phenols and alcohols, phenols are more acidic than alcohols, and depending on the substituent, that is whether it is an electron withdrawing group or electron releasing group, this will increase the acidity, whereas electron releasing group will decrease the acidity of phenols.